I'm going to go through the differentiation assignment as it was quite tricky. The first time we do the C3 stuff is not the easiest stuff in the world. So I'm going to go through each of these. Okay, so number one, we've got the following question. It says differentiate with respect to x to and simplify your answer where possible. So we've got this expression e to 3x cos x. Now before you go any further, we're doing differentiation today or integration. We're going to write down this at the top of our page. Sin x cos x minus sin x minus cos x. That's it. Going down the line, we're differentiating. Going up the line, we're integrating. I want you to write that on every page whenever we're working differentiation or integration in C3 and in C4. Now, the reason why this isn't as easy to differentiate as we would have been used to is because there's something with x in there, something with x in there, and they're not adding and subtracting, they're timesing. That means we're using the product rule. So u times by v. Now we're going to set it out as u equals e to the 3x, v equals cos x. So I can write cos, there we go, cos x. And then u dash, so we differentiate each of these individually. So u dash would just be 3e to the 3x. If you're unsure why that is, run it through the chain rule. Okay, I'm not going to go through every single tiny little bit today. You need to go and look back in your books. And then cos differentiates to minus sine. So that becomes minus sine x. The product rule states that if you have u v dash, I'm just going to change pens. It shouldn't happen again. States that if you have y equals uv, then the differential would be uv dash plus vu dash. That is given to you in the formula booklet, not quite in the same format. I like to remember it like that. So basically I need to multiply the diagonals together. So I'm going to get e, so y dash is equal e to the 3x times by minus sine x plus 3e to the 3x and then times that by cos x. Now purely just because I want this to look a bit nicer, I'm going to get the positive thing at the front. So I'm going to say y dash is equal to 3e to the 3x cos x and then minus e to the 3x and sine x there. Now that is not simplified because I've got e to 3x in both, so I'm going to pull that out as a factor. That's the only thing that goes into both though. So e to the 3x bracket 3 cos x minus sine x, and that would be simplified as much as possible. Next question. This says tan 5x squared plus 3. Now the good news about differentiating tan, so this is technically y equals, and we say dy by dx equals to differentiate it. The good news is that is given in the formula book. Tan differentiates to sec squared. But the best thing to do with this, because it's not tan x, it's tan, and then it's got this product, is we're going to say let, so I'm going to write this out fully now, let u equal 5x squared plus 3, so y is equal to tan of u. I then differentiate these separately, so differentiating u with respect to x, I get 10x, that's just 10x, isn't it? And then dy by du would give me sec squared u. Okay? To get dy by dx, I multiply together du by dx times by dy by du. And what that does is cancels the du's out, giving me dy by dx. So that is going to give me a total answer of 10x. Now I could say sec squared u, but I know what u was. U was 5x squared plus 3. So you end up always getting this original function back here in your differential. Okay, same with integration as well, it will always be there. And then part C, ln of 2x. Now, I told you a rule for when you're differentiating ln. We said it was the differential over the original. Very easy then, this one. So dy by dx is equal to the differential of 2x, which is 2, over the original, which is 2x, and then 2 and 2x becomes just 1 over x. And that was the first question. Second question. Okay, so this is requiring you to recall a bit of C1 knowledge, where it says, find the x-coordinate and the nature of the stationary point of the curve given by y equals, so number 2, y equals e to the 2x minus x minus 1. Dy by dx then. So these aren't multiplying, these are just take away signs, so that's nice. That means we can literally just differentiate each individual part. E to the 2x differentiates to 2e to the 2x, and then minus 1. Okay. Now, for stationary points, what you should remember for stat points, you should remember that dy by dx is going to equal 0. Okay. So I can put 0 is equal to e to the 2x minus 1. I'm now going to solve that as an equation to get a half is equal to e to the 2x. So what I need to do now is grab a calculator, and also I need to know what e to the 2x is going to change to when I take it over. You should know that the opposite of e is ln. So when I take e over, it becomes ln. So it becomes ln half is equal to 2x. And then I would halve that to get rid of the 2, wouldn't I? So I'm just going to put into my calculator fraction ln, I'll just say 0.5, same thing, same half, divided by 2, and I get the following answer. Minus 0. Now it says in the question, no it doesn't say. In these sort of questions I would tend to go to about 3 decimal places, but if I'm doing any further work with this coordinate, I'll leave it in my calculator as ants. Okay, so I'm going to go to 3dp and say that's minus 0.347 to 3dp, and that's my value of x. Okay, I've not quite finished yet though. It says determine the nature of the stationary point, so you need to remember how to find the nature of the point, which is double differentiating. So d2y by dx squared would give me, so I'm looking at this thing and differentiating this again, so that's going to do the 2 times the 2 there, which is going to give me 4 e to the 2x, and that's it, because the 1 would just go. And I'd say when x equals minus 0.347, d2y by dx squared is equal to 4 e to the 2 minus 0.437, and then I'm putting that into my calculator as 4e 2 ants, and I get the answer 2. You know, that's telling me I've done all my work right, isn't it? The chance of me getting 2 there when I had such a long rank numbers is filling me with confidence. That 2 is positive, bigger than 0, therefore it is don't fall for it, it's a min. Okay, it's a min value. Okay, number 3. Okay, so number 3. Let me go and grab some more paper so I can start writing those. Okay, so the first one is the quotient rule. We actually haven't done that yet in this video, but we've done the other rules that are within this. So for question 3, we've got ln x over x squared. So the way I know that's the quotient rule, it is some form of x dividing another form of x. So what I write is u over v. Now, the quotient rule states that if you've got y is equal to u over v, then y dash would be equal to v u dash minus u v dash all over v squared. So I need to just state u equals v equals. So in my case, u is equal to ln x, v is equal to x squared, u dash is equal to 1 over x, and v dash is equal to 2x. So v u dash, that is x squared times by 1 over x. So I'm going to say y dash equals x squared times by 1 over x. If you're really good with the maths, you could just say that cancels out to x straight away if you're happy to, but I'm going to show you properly. And then uv dash is the other way around, so it's going to be 2x ln x all over the original thing, so the original v that is, x squared squared. So that is going to become x minus 2x ln x, and then all over x to the power of 4. Not simplified because x there and then x there, so let's pull that out, so we get x, we get 1 minus 2 ln x, all over x to the power of 4, then that x there will cancel the power there, so it'll give me a final answer of 1 minus 2 ln x over x cubed. Okay, next thing is b. Now b's a little bit sneaky, 3b, because it says root 1 plus 6x to the power of 4. You should be thinking of that as 1 plus 6x to the power of 4 to the half. Okay, so then you can run this through the chain rule, or if you're getting really good at it, you think you know what you're doing, you can do it very quickly. I'll run it through the chain rule, but then we'll look at like a quicker way to do it. So we're going to let u equal 1 plus 6x to the 4. So du by dx would equal what, 24x cubed, and y would now be equal u to the half. So dy by du would equal a half u to the minus a half. Okay, and then multiplying those things out to find out what dy by dx is would give me half of 24, so 12 x squared, and then I could just put that original bracket 1 plus 6x to the power of 4 to the minus a half. That is correct, but you can write that, you might see it in the mark scheme as this, 1 plus 6x, like that, and then to the square root like that. That would be, oh, you can't see what I'm doing. That would be like another version of write it, because the minus means 1 over, and then the half means square rooting, so that might be the very, very final answer. But that line there is technically correct. Let me just check what it says in the mark scheme. Yeah, it's got my version in the mark scheme, it's got this one here. Although I did just realise, for some reason I changed that to a squared when it should be a cubed. Okay, I've got a cube there, it should be cubed there. Okay, and the same there, it should be cubed there. Okay, and then 3c is x cubed tan 2x. Okay, right, I'll probably be a bit careful with this one as well. So that is one form of x multiplied by another form of x. So u dash, let's write u equals x cubed, u dash is equal to 3x squared, v equals tan 2x, v dash is going to equal, now if needs be, run it through the chain rule. I think I know what the answer is. I think it's 2 sec squared 2x. Okay? Then product rule, that times that plus that times that. So I'm going to get 2x cubed. You tend to get the number at the front and then powers of x and then trig afterwards. So 2 sec squared 2x and then plus 3x squared tan 2x. So then I'm going to pull out what? Certainly x squared, that's the smallest of the two powers there. X squared. And then that's the only thing that comes out, I think. So x squared, and then I get 2x sec 2x, sec squared 2x, and then plus 3 tan 2x. I'm hoping that's right. Yeah, that's right. In fact, actually, in the mark scheme, they haven't even taken the x squared out. I think you should do, because that is then fully simplified, and it says simplifying your answers where possible. So make sure that you go as far as you possibly can. And then finally, is it finally question 4? No, I lied. There's some stuff in the back. Oh yeah, it's quite a long one, isn't it? So question 4, x squared ln x. This is an easy one, u dot v. So u is equal to x squared, u dash is equal to 2x, v is equal to ln x, v dash is equal to 1 over x. Okay? So from there, we're just literally going to do that multiplying cross. So y is equal to x squared times by 1 over x will give me just x. And then plus 2x ln x. And again, can I pull out a factor of that? Yeah, x, and then 1 plus 2 ln x. Pretty similar, wasn't it? It's the one we've already done. And then for b, x squared plus 1 over x squared minus 2 is equal to u over v. So u is equal to x squared plus 1. And then 2x would have been its differential, and then v dash would equal x squared minus 2, and v dash would equal just 2x. So I'm just going to write out the product rule again. So y dash is equal to v u dash minus u v dash, and then that's over v squared. So I'm going to get y dash is equal to v u dash, so it's like the opposite of the product rule, so not that times that this time, but 2x times by that one, so 2x x squared minus 2, and then minus 2x, and then x squared plus 1, over x squared minus 2 all squared. No need to actually do any simplification of the bottom, that can just stay as that, because if you expand it out, you go, oh, doesn't that factorise? So no need to do anything with that. So that's going to give me 2x cubed minus 4x. Careful with this, minus 2x times x squared would be minus 2x cubed, but then I'm going to get plus, because minus times by, no I'm not, that's a lie. I'm going to get minus 2x there, from minus 2x times by plus 1, all over this thing, x squared minus 2 squared. 2x cubed and minus 2x cubed cancel, giving a final answer of minus 6x all over x squared minus 2 squared. Okay? Over the page, we've got now on to question 5. Oh, okay. These ones aren't the easiest things in the world. You just have to take your time with this. I think we did this one in class, so I'm hoping I can do it now. But they are hard. So, you know, the C3 isn't easy. So first by writing tan x is equal to sine x over cos x. Okay, where's that first sheet I did? Obviously can't find it now. Then let's write it down again, because this is really important. So sine x, cos x, minus sine x, minus cos x. Going down, I'm diffing. Going up, I'm integrating. Okay? So I've got a function of x divided by another function of x. That means I'm doing the quotient rule. So u is equal to sine x, u dash is equal to sine goes to cos. So sine goes to cos. So v there. V would be equal to cos x, and v dash, cos goes to minus sine. So then the product rule states that I do cos times by cos. So I'm going to get cos x times cos x. And then I'm going to take away sine x times by minus sine x. All over the bottom one, so cos x squared. Now that gives me cos squared x, and then minus times by minus is going to give me plus sine squared x, all over cos squared x. Okay? What do we know about sine squared plus cos squared? Although, it should have a squared there, shouldn't it? Sine squared plus cos squared from C2. Sine squared plus cos squared, I know this says cos squared plus sine squared, but it's the same thing as if I flipped it round, would give me 1 over cos squared x. And then if you remember, there are these things called sec, cosec, and cot. Look at the third letter in each. The third letter C tells me that is sec squared, which is exactly what they wanted in the question, if you have a look there. Okay, then final one, number 6. So number 6 is 9 minus 2x to the power of a third. Now again, if in doubt, chain rule it out. Okay? If it was me, I'd probably chain rule it because it's quite nasty. It's got a third and then minus 2x. I'm not going to risk trying to do it in my head. So I'm going to let u equal 9 minus 2x. So y equals u to the power of a third. Du by dx equals minus 2. dy by du is equal to a third u to the minus 2/3. So then dy by dx is equal to minus 2 times by a third would be minus 2/3, and then it will be the original bracket, this thing here, 9 minus 2x, that's the u, and then to the power of minus 2/3, and that answer's fine. I'm not going to bother simplifying that. I'll quick check they did in the I'll show you what they wrote in the official answers. So they said minus 2/3, and that's a minus, that's going to bring that down. So it's minus 2 all over 3, 9 minus 2x, and then to the 2/3 here. Okay? That and that are the same thing. That looks slightly nicer. If you're going to sub into that without a calculator, I'd much prefer to sub into that form, but we're not going to, and you should get the marks up till there, to be honest, because you've done all the processes. Okay, B is quite interesting. Ln cos x. If in doubt, chain rule it out. U equals cos x. So y is equal to ln of u. The differential of cos x, let's just check. Differential of cos goes to minus sine. So minus sine x, and then dy by du would equal 1 over u, and then times them together to get dy by dx. So I can get minus sine times by 1 times the tops together would give me minus sine x up on the top, all over u, so the original was cos x. Sine over cos. Hello, what have we got here? You can see what I'm drinking now, little sine over cos equals tan. So that's going to equal minus tan, isn't it? Okay, and then, I'm happy with that. I got that in the old mark scheme. So these things come with time. You just keep on doing more and more of these questions, so you'll get more and more confident with them. Okay, last one is a bit of a pig of a question to finish on. We've got e to the 6x all over. It's got the chain rule chucked in. This is a really hard question. Okay, so this is u over v. Okay, something with x over something with x. So u is equal to e to the 6x. U dash is equal to 6e to the 6x. V is equal to 3x plus 2 to the power of 4. V dash. Now really, if you're unsure, you should chain rule it out. I'm going to try and do it really quickly. It's the differential of the bracket, so 3 times by the power, so it's going to be 12, to the original bracket, reduce the power by 1. Okay, that's how you do it really quickly. But you saw on like when I did over here, I thought, oh, I don't want to do that. If I wanted to do that one really quickly, I would have differentiated it. So minus 2 times by the power, so minus 2/3, reduce the power by 1. And that's exactly what I did get by here. But I just thought, oh, it's quite nasty numbers. These weren't so nasty, so I thought, no, it's easier to do. So chain rule is VU dash minus VU dash. No, that's the same thing, isn't it? VU dash minus UV dash all over V squared. So I need to have 6 e to the 6x, and then I get 3x plus 2 to the power of 4, minus, and then it is going to be 12 e to the 6x, and then 3x plus 2 cubed all over the original, so that's 3x plus 2 to the power of 4, that original thing squared. Oh, this is hard. Okay, there's loads of things in common. This is not simplified yet. Okay, so 6, 12, I can bring out a factor of 6. E to the 6x, e to the 6x, I can bring out e to the 6x as well. And also 3x plus 2 to the power of 4, 3x plus 2 to the power of 3. I bring out the thing with the smallest power. So 3x plus 2 to the power of 3. That's all in common. What do I need to times this by to turn it into that? Well, I've got the 6, I've got the e to the 6x, that's there. I've got this bracket, but that's the power of 3, that's the power of 4. So I need another version of that bracket to the power of 1, because if you add those two powers together, it would make to the power of 4. I then take away, and then 6, 12, so that would be 2. E to the 6x is there, and that bracket is already there, so that's fine, that's it. Okay? And then on the bottom here, I've got 3x plus 2 to the power of 8. Okay? Now from there, to the power of 1 means I don't really need those brackets. So I've got 3x plus 2 minus 2. They cancel. I've got 3x plus 2 on the top and on the bottom. That's the power of 3. So I can take that off that power there, becomes 5. Finally, 6e6x times by 3x will become 18e, so 18, oh, goodness me, it's fussy, isn't it? 18x e to the 6x all over 3x plus 2 to the power of 5, and that was the final answer. Yeah, look. There's the mark scheme. Hopefully, I've shown you exactly where all those steps come from now, okay? But that was the assignment. It should have taken you a while, that one, okay? It was hard, that's why I've done the video on it. If there's any issues, give me a shout. I don't mind doing these, okay?